Next problem, problem number 3.26. Now this is based on the data of example 3.1 part C. There it has been shown that how to find out the rate equation by using the fractional life method, where this f was 80% or 0.8, that is the fraction in terms of percentage 80%. Take the data from that example and find the rate equation by using half life. So instead of fractional life we have to use half life. So fraction in place of 0.8 for half life it will be 0.5. It is suggested that take CA0 values as 10, 6 and 2. We know T half is equal to 0.5 raised to 1 minus n minus 1 into CA0 raised to 1 minus n divided by k into n minus 1. Now this is the equation which we have derived earlier. If you take ln of both the sides, natural log of both the sides, ln of T half is equal to ln of this complete term when k is constant, n is constant for a given reaction. So this we have written as ln of this complete constant plus 1 minus n into ln of CA0. So if I want to represent the data on a straight line, I will plot ln of T half as y and ln of CA0 as x, and we will get a line, straight line, y is equal to mx plus c form, where m will give you the value of 1 minus n, that will give you the slope, and from slope you can calculate or find out easily order n, and you know n, this anti-log of this intercept will give you this value. N is known, now only k is unknown, you can find out easily. So what is suggested is, so this concentration time curve is the data plotted from the solved example. You go through that example first. Okay. So this has been plotted. Now this represents concentration. You can check CA0, then CA0 is changing, that is concentration, and corresponding concentration values also you can find out from this part. So this essentially represents concentrations. You can read CA0 value and CA value also for these points. So CA0 is equal to 10, half life for 50% conversion, so CA will be 5. For CA0 is equal to 6, CA will be half of this 3. CA0 is equal to 2, CA is 50%, that is 1. So these points are marked here. This represents CA is equal to 5 here, then CA is equal to 3 here, and CA is equal to 1. So these lines parallel to x-axis represent our CA values for half life, 50% of the conversion. T corresponding to CA0 values. When CA0 is equal to 10, T is equal to 0. When CA0 is equal to 6, this value you can read CA, and that is you can read T time, that is 40. Third value, CA0 is equal to 2. When CA0 is equal to 2, this is the corresponding time, that is 180. Okay. Now time required to reach half of this value. So in each case we will see that. So for first point, CA is equal to 5. So for CA is equal to 5, this value is 60. Then CA is equal to 3. From here you have to read, this is 120. CA is equal to 1. From here this is 300. Okay. So corresponding value of T half. So from 10 to 5, 10 to 5, this particular 60 minus 0 is 60. Second, it starts with 6 and ends with 3. So 120 minus 40. Okay. and last point 300 minus 180, so 120. So we got T half, we know CA0. So ln of T half and ln of CA0 computed here, and that we plot here. Okay. So on this axis you have ln of CA0 and here ln of T half. Okay. This is ln of T half and this is ln of CA0. So the best fit line equation, you get y is equal to minus 0.42x plus 5.092. Okay. So slope is this 1 minus n. 1 minus n is minus 0.42. So order is 1.42. Intercept is 5.092. So antilog exponential of the intercept is 162.71. That is the value of this constant. Okay. So you can calculate k is equal to 0.5 raised to 1 minus n minus 1. In the denominator you have n minus 1 and this value, constant value, this c, e raised to c will go in the denominator and you can calculate k. So k is equal to 0.5 raised to 1 minus n is minus 0.42 minus 1 divided by n minus 1, n is 1.42 minus 1 and exponential of the intercept 162.7. So when you calculate this, you get k as 0.005. So minus RA we can write as 0.005. We need this 5 here. Okay. So 0.005 minus RA is equal to 0.005. CA raised to n, n is 1.42. So this is the rate law which we have obtained for the data of example 3.1, where fractional life method was used for 0.8. Same problem we have solved by half life method, and we have taken the data which is suggested. CA0 is equal to 10, then CA0 is equal to 6, CA0 is equal to 2. And if you compare the final result, you will find K is same value and CA is almost same. There it is 1.4 in solved example, it is 1.42 here.